So let us start the second day of this workshop, and we have the first plenary speaker for today, Professor Abhijit Majumdar from IIT Bombay. So it's a plenary talk, so it's around 45 minutes total time. So you have to have 40 minutes for the presentation, and then we have a 5 minutes for the discussion. Please.
So thank you, Professor Abhijit. Thank you, Shubhanjan, for this wonderful opportunity and to be here for this meeting. So essentially, what I will be talking. Can we get these lights off?
Okay, yes.
So this work that I'm going to talk about, mostly. So that is in collaboration with Professor Shilpi Dutt from ACTREC. Now she is in JNU. Essentially, this collaboration started in one of such gathering, and over the lunch we were discussing something, and then we thought that okay, we can work together. So Shilpi's student Anilha and my then student Pallavi, they started the work together, then taken up by Ketki, and this is the kind of one part of the work. And then Dr. Arpita, who is a postdoc, joined my lab, and she taken the work forward with the present collaborator, Professor Mohit Jolly, and his student Sandalia from IISc. So, but before I go into today's talk, first let me talk about from where I come. So Paris is known as City of Light as well as City of Love. So this is a night view of our campus. It is, again, you can see that also a beautiful with the lights. And the campus is essentially, I come from IIT Bombay, between two lakes and the hills, as you can see here. And this is the westernmost part of the country. And yesterday, with someone we were discussing that from the easternmost part of the India to the westernmost part of the India, time gap is 2 hours. The local time gap is 2 hours. So that's why we say in India we have many countries inside one country. So IIT Bombay, we have 10,000 students and various different, I think 34 plus department plus centers. I belong to Department of Chemical Engineering, where we have 45 faculty members working in various different areas of chemical engineering. So what my lab do? So what my lab does, so when I started my lab, we started to call it the M lab. M here stands for, that point of time I thought my lab works for the mechanobiology and the microfluidics, both are with M. I am Majumdar in Mumbai, so it's a nice M lab. Later on, in the last 10 or 11 years of journey, I have realized that M actually has a deeper meaning. And what we are essentially trying to do is to mimic the microenvironment in our lab. So the tissue microenvironment that happens, in our body, that we try to mimic in the lab, and that is the bigger picture that we are trying to do. So, when I say mimic or mimicry, it is not making a clone. I am not trying to make a clone of something, but I am trying to mimic. So then what is the meaning of mimic? Meaning of the mimic is that you don't need to copy every finite details. You need to realize or recognize which are the important details that if you copy, it will serve the purpose. Like this. You don't need to copy everything to tell what this is or what it is. But it can capture the essence that we want to capture. Similarly, in our lab, we are trying to do is that we are using one arm, that is our mechanobiology arm. There we try to understand how the various different mechanical property of the tissue, like rigidity, structure, porosity, topology, that may influence the various cellular behavior. And on the other hand, we are working with the microfluidics, where we are trying to mimic the perfusion, shear stress. Yesterday during the talks, we heard from the Rajdeep's talk about the shear stress. So that is something we are trying to do. And from that, we are trying to make various organ on chip. Again, yesterday we heard about the liver on chip and the gut liver on chip. So that is what we, our lab is working on. For today's talk, it will be mostly focused on this mechanobiology part. And there we will be particularly focusing on our one application, that is the glioblastoma. So for the general kind of discussion, so that we all are on the same page, what is glioblastoma? So glioblastoma is essentially one of the brain cancer that forms that starts from the glial cells, and this is one of the deadliest cancer. If one person gets detected with glioblastoma today, with all the surgery, chemotherapy, radiotherapy, everything, you can remove the primary cancer of the primary tumor, but almost with most certainty within 6 to 10 months, the tumor will relapse. And the relapsed tumor is known to be much more aggressive. And the thing is that this is from 1967, this is from 2014, things have not changed in last 10 years also. You can see that the life expectancy has not changed much. Even in last 50 years, we have progressed a lot in many other cancers. In many cancers, we have often say that, okay, we have got the win over this cancer. Not true for the glioblastoma. We have not moved much. And one drug that is available, the mostly used, the chemotherapeutic drug, is the TMZ or temozolomide. Now, as I was telling, is that it is the parent tumor, you do everything, but still you remove the tumor cells, not all the cancer cells that you can remove, okay? Some will still stay back, and then they form the relapsed tumor within 6 to 8 months. And it has been clinically seen that the relapsed tumor is much more aggressive. And when I say that aggressive, the meaning is that they are highly proliferative, highly invasive, they are drug resistant. So in some sense, I can say that if a patient is going through the treatment, then the patients are dying not because of the parent tumor, but because of the relapsed tumor. So we need to really understand the biology of the relapsed tumor. And for that, we need a model. Now you need to understand here one more interesting thing, is that, as I said, the parent tumor will go through the surgery. It will, after that, the tumor will relapse within 6 to 8 months. But that time it is highly invasive. It has almost covered. It is not coming.
Yeah, because just share the slide with because people are
Achha, achha. Sorry.
I forgot that.
Sorry about that. Don't count the time.